In today's lesson, I will discuss the second review, the multiple choice questions, AS level physics. And I will start from number 1. A metal sphere of radius r is dropped into a tank of water. As it sinks at speed v, it experiences a drag force F. And an equation is given, F equals KRV, where K is a constant. We want to find the SI base units of K. So here radius is r is radius, the unit, the base unit is meter. V is speed, the base unit is meter per second. Mf is force, the unit is Newton, and the base unit is kilogram meter per second. So if we want to find the SI base unit of K, we'll just have to change this equation into K equals F over RV. F is in the unit of Newton, R is in the unit of meter, V is in the unit of meter per second, and Newton is kilogram meter per second squared, divided by meter squared over second. So it will become kilogram meter to the minus 1, second to the minus 1. So the answer is C. Number 2. The resistance R of a resistor is to be determined. The current I in the resistor and the potential difference V across it are measured, and the results with the uncertainties are given. And the value of R is calculated to be 7.5 ohms. We want to find the uncertainty of this value R. So we know that percentage uncertainty is equal to uncertainty divided by measured value multiplied by 100%. So for this I, the percentage uncertainty will be the uncertainty 0.2 divided by the measured value 2 multiplied by 100%. It is equal to 10%. For this V, the percentage uncertainty will be 0.5 divided by 15 multiplied by 100%. So if we want to calculate R is equal, this is 3.33%. R is equal to V over I. The V is 15 divided by 2. This is the measured value. So R is equal to 7.5 ohms. And to find the uncertainty, percentage uncertainty, we have to add the value. Percentage uncertainty is equal to 3.33% plus 10%. Because it is divided, then we have to add. Then it is equal to 13.33% or 0.133. So to find the uncertainty, just multiply this value to the value, the calculated value of R, 7.5 ohms. And it is equal to 0.99 and so on. It is equal to 1 ohm. So the answer is D. Number 3. On a particular railway, a train driver applies the brake on the train at a yellow signal here, a distance of 1 kilometer from a red signal where it stops. So here it stops. The maximum deceleration of the train is 0.2 meter per second squared. Assuming uniform deceleration, what is the maximum safe speed of the train at the yellow signal? So I'm going to write down the given quantities here. The distance from the yellow to the red signal is 1,000 meter, 1 kilometers. The deceleration, maximum deceleration is 0.2 meter per second squared. I think this should be meter per second squared. And it is negative because it is decelerating. And then V is 0. The velocity at this point should be 0. So we want to find U. U is the velocity of the train at the yellow signal. So here I'm using this equation. V squared equals U squared plus 2AS. V is equal to 0. U is what we're going to calculate. A is minus 0.2. So you can calculate U squared to be 400, and U is equal to 20 meter per second. So the answer is A. Number 4. A cyclist pedals along a raised horizontal track. At the end of the track, he travels horizontally into the air and onto a track that is vertically 2 meters lower. So this track is 2 meters lower. So the cyclist travels a horizontal distance of 6 meters in the air. Air resistance is negligible. We want to find the horizontal velocity here at the end of the higher track. So here we can see that this cyclist will travel a projectile path, but not a complete projectile path. So we can see here that the vertical distance he travels is 2 meters. So this is the vertical distance. Y equals phi 0y, the vertical component of initial velocity, times t minus a half gt squared. So I will substitute y using minus 2 meters. Y negative because it is below our point of reference. I'll take this as my point of reference. Phi 0y is 0 because it starts moving from here with horizontal component of velocity only. Minus a half times 9.8 times t squared. So you can calculate that t is 0.64 seconds. So he needs 0.64 seconds to reach the lower horizontal track. And then this is x, the horizontal distance, phi 0x multiplied by t. X is 6 meters, phi 0x is this one, the horizontal component of velocity, multiplied by the time, which we calculated. So v here is 9.4 meter per second. So the answer will be B. Number 5, a body experiences a varying resultant force that causes its momentum to vary as shown in the graph. So we have here momentum against time graph. At which point does the resultant force have the largest value? You have to remember this equation. F is equal to delta momentum over delta time. And delta momentum over delta time in this graph is equal to the gradient of the graph. So when we want to find the largest value of resultant force, then it means that we have to find the largest gradient. It means that we have to find the steepest graph, yeah, which we can see here that the steepest one, the largest gradient, will be given by this point B. Number 6, the diagram shows a barrel suspended from a frictionless pulley from a building. The rope supporting the barrel goes over the pulley and is secured to a stake at the bottom of the building. A man stands close to the stake. The bottom of the barrel is 18 meters above the man's head. The mass of the barrel is given 120 kilograms. The mass of the man is 80 kilograms. The man keeps hold of the rope after untying it from the stake, and he is lifted upwards as the barrel falls. So we want to find the man's upward speed when his head is level with the bottom of the barrel. So this barrel will fall and he will be lifted upwards, and there will be a certain time where when his head is level with the bottom of the barrel. I guess that's when it reaches half of 18 meters. It reaches a distance of 9 meters, and this one reaches the distance of 9 meters. Yeah, so first of all, I would like to draw all the forces that act on the barrel. I have this weight. The weight is 120 multiplied by 10 meter per second squared. That will be 1,200 newtons. And I have the weight of the man, which will be lifted by the rope here. The weight is 800 newtons. Yeah, there will be tension here, tension there. But when we see this system, we analyze this as a system, then we can eliminate those tensions. So we can use the resultant of forces equals mass times acceleration. The resultant of forces will be due to the weight of the barrel, minus tension plus tension minus tension plus tension here, and minus 800. So we have 1200 minus 800 equals, the total mass will be 120 plus 80, the total mass, multiplied by acceleration. The acceleration of the barrel and the man will be the same. Yeah, so here I have 400 equals 200A, so A is equal to 2 meters per second squared, both for the barrel and also the man. So when we want to find the speed of the man when his head is level with the bottom of the barrel, that means that it is traveling a distance of a half times 18 meters. The distance he travels is 9 meters. So we can use this equation, v squared equals u squared plus 2as, given the initial velocity 0, because initially the system is at rest. So now we can calculate v, which is equal to 0 squared plus 2 times 9. V squared equals 36, and v is 6 meters per second. And the answer will be A. Number 7. A uniform electric field is created by two parallel vertical plates. A positively charged particle is in the vacuum between the plates as shown. We want to find which statement is correct relating the electric field and the movement of the particle. We have to see here that F is equal to Q multiplied by E, where E is the electric field strength. So this E, this electric field strength, will give a certain force to a charged particle. So that when there is a charged particle inside an electric field, then there will be a force. That force is given by mass times acceleration. So we have the equation of Q times E equals mass times acceleration. So there will be acceleration due to that force, Q times E. So I guess here the charged particle will move, but not with a constant speed, because we have a constant acceleration. So the electric field will make the particle move towards the negative plate with a certain constant acceleration. So the answer is B. Number 8. A cylinder of weight W is placed on a smooth slope. The contact force of the slope of the cylinder is R. A thread is attached to the surface of the cylinder. The other end of the thread is fixed. We want to show which diagram shows the cylinder in equilibrium. Remember that for the equilibrium, there are two conditions that must be fulfilled. The resultant of force should be equal to 0, and the resultant of torque should also be equal to 0. So for this option A, I want to draw the forces that act on this system. I have this tension force of the thread. I have the component X component of weight and Y component of weight. So here the normal will be equal to the Y component of weight, but this tension and that Wx, the X component of weight, will create torque on the system. So the resultant of torque is not 0, so in this case it will not be in equilibrium. The same with B. Remember that torque is a force multiplied by perpendicular distance from the line of action of force to the axis of rotation. So here this tension will also create torque on the system. Although we have weight Y, which is equal to R, and even though tension is equal to the X component of weight, but although the resultant of force is 0, there will be the resultant of torque here. So it is also not in equilibrium. What about C? we have tension here, we have the component, the x component of weight and the y component of weight. And here we can see that this tension will not create torque on the system. So I guess this one can be in equilibrium when R is equal to the y component of weight, and when this tension is equal to the x component of weight, then this will be in equilibrium. So the answer is C. Number 9. A box of weight 30 newtons is released from rest on a ramp that is at an angle of 30 degrees to the horizontal. The box slides down the ramp so that it falls through a vertical distance of 8 meters. A constant frictional force of 10 newtons acts on the box while it is moving. We want to find the kinetic energy of the box after falling through this distance. I think to solve this problem, we can use the conservation of energy. At the top of the inclined plane, there is only potential energy because it is released from rest. So there is no kinetic energy here. We have only potential energy, which is equal to mg, or the weight, multiplied by the height. The weight is 30 newtons multiplied by the height, 8 meters. It is equal to 240 joules. But along the way, there is friction. So there will be energy lost due to friction. And to find that friction, we have to find this length of the ramp. We can see this triangle, and we can write down that the sine of 30 degrees is equal to the height divided by this d, and this d will be equal to 16 meters. So this box will go down the ramp along 16 meters, and that's when there is energy loss due to friction, which is equal to the friction force multiplied by the displacement of the box. Then it is equal to 160 joules. So here at the bottom of the ramp, there is kinetic energy only because the potential energy is 0 here. It is equal to 240 minus the energy lost due to friction, 160. It will be equal to 80 joules. So the answer is A. Number 10. The diagram shows two liquids labeled P and Q which do not mix. They do not mix because their densities are not the same. Yeah, the liquids are in equilibrium in an open U tube. So this is a U tube, and we can see that there is pressure here at this point. I call this P1. That will be the same as pressure there, P2. And this P1 is due to the liquid above it. This P2 is due to the liquid above it, which they are not the same. Yeah, so I can use the equation P1 equals P2. P1 is the hydrostatic pressure at point 1. It is rho of P multiplied by G multiplied by H1 here. And P2 is equal to rho of Q times G times H2. And I can cross G out. So I have rho P times H1 equals rho Q times H2. We want to find the ratio of density of P over density of Q. So rho P over rho Q is equal to H2 over H1, where H2 is X and H1 is 2X. So rho P over rho Q will be a half. The answer is A. Number 11. Water has a density of 1 gram per centimeter cube, and glycerin, the density is 1.3 gram per centimeter cube, and we have a volume of 40 centimeter cube of glycerin into a container, and then the student adds water to the container to make a mixture of water and glycerin. Yeah, assume that there is no change in total volume when the two liquids are mixed. Which volume of water needs to be added to make a mixture of density 1.1 gram per centimeter cube? we have to use the equation of the mixture, the density of the mixture. It should be the total mass divided by the total volume. Yeah, the total mass is the mass of water plus the mass of the glycerin divided by the volume of water plus the volume of glycerin. So mass is equal to rho times volume. So I have rho of mixture equals rho of water multiplied by volume of water plus rho of glycerin multiplied by volume of glycerin. And I will substitute this rho of mixture by 1.1. It is equal to rho of water 1 multiplied by the volume of water, which we want to calculate, plus the rho of glycerin is 1.3 multiplied by the volume of the glycerin is 40 divided by the volume of water plus the volume of glycerin is given 40. Yeah, so I can calculate here that the volume of water is equal to 80 centimeter cube. Yeah, so this is the answer. Number 12, a diffraction grating is used to measure the wavelength of monochromatic light as shown in the diagram. You are given the spacing of the slits 1 times 10 to the minus 6 meter, and the angle between the first order maximum, the diffraction maxima, is 70 degrees. So we want to find the wavelength of the light. The equation that we use is this: d times the sine of theta is equal to n lambda. This d is the spacing of the slits, so I have this. The theta is the angle between the first order maximum to the center bright fringe. So when we are given the angle between the first order maxima, and we want to find the angle between the first order maximum to the central bright fringe here, then it should be 70 divided by 2, 35 degrees. It is equal to lambda. Then you can calculate lambda to be 5.74 times 10 to the minus 7 in the unit of meter, and convert that to nanometer. 1 meter is 10 to the 9 nanometer, so it is equal to 574 nanometers. The answer is C. Number 13, for solid steel rods, each of length 2 meters and cross-sectional area 250 millimeters squared, equally support an object weighing 10 kilonewtons. The weight of the object causes the rods to contract by 0.1 millimeter. The rods obey Hooke's law. What is the Young modulus of steel? If we have 10 newtons divided by 4, supported by 4 rods like this, then each rod will support only 10 over 4 kilonewtons of weight, 2.5 kilonewtons of weight. So when we want to find the Young modulus, it is stress over strain, and stress itself is F over A. Strain is delta length over length, original length. It is equal to F over A multiplied by original length over the extension or the contraction here. So I can calculate F to be 2500 newtons divided by the area. It is 250 millimeters squared, or you have to convert to meters squared multiplied by 10 to the minus 6 multiplied by L, which is 2 meters, divided by the delta L. You have to convert into meters also. So the Young modulus, we calculate it to be 2 times 10 to the 11 Newton per meter square. So the answer is B. Number 14, the diagram shows an electric field pattern caused by 2 positive and 2 negative point charges of equal magnitude placed at the 4 corners of a square. In which direction does the force act on an electron at point X? We know that the direction of electric field is from positive to negative. So here we can see that the direction of electric field is shown by the arrows here. Yeah, the electric field lines at any point shows the direction of the force on a positive test charge. Yeah, so the electric field lines, those electric field lines show the direction of the force on a positive test charge. Since now we are dealing with an electron which has a negative charge, so the direction of the force on it will be opposite to the direction of the force on a positive charge. That is indicated by the direction of the field. So here at x, the direction of the force will be upwards because it is an electron negatively charged, and the the direction of electric field lines is downwards, so it will be upwards. So the answer is this B. Number 15, a potentiometer is used as shown to compare the EMFs of two cells. The balance points for cells X and Y are 0.7 meters and 0.9 meters respectively. The EMF of cell X is 1.1 volts. We want to find the EMF of cell Y. We have to remember this, the second Kirchhoff's law. The sum of EMF is equal to the sum of potential difference, and R is rho times L over A. These are resistance. Then we can say here that EMF is proportional to L. L is the length of the wire. So EMF of X divided by EMF of Y will be equal to Lx over Ly. EMF of X is given 1.1. We want to find EMF Y. Lx and Ly are given. So we can calculate that the EMF of Y is equal to 1.4 volts. The answer is D. Okay, that's all. Please prepare well for the quiz on Friday. The questions will be more or less just like what we have been reviewing from Monday to today. So please prepare your best. Thank you.